Greetings all and welcome to our weekly tap room. Today we're gonna discuss StarWind Virtual Sun and its grid architecture. Also, we'll try to bring down the failover cluster powered by StarWind and make sure it's not that easy. Rest assured, it will be fun, so you boys better stock up on beer or whatever you like. At once I would like to make a reservation. About 2 weeks ago we already discussed this topic, but unfortunately it wasn't recorded due to the technical challenges we faced during that webinar. So I've decided to still record it offline and upload on YouTube so you can refer to it when it is necessary. And just before we get started, let me say a word about myself. My name is Bogdan and I am Solutions Engineer here in StarWind. You know guys, this is kind of very interesting job. Maybe it's quite hard to explain in a word, but one thing's for sure, you don't get to be bored. I would say never. Alright, it's all about formalities, so let's just cut to the chase. So today's agenda is on the subject of StarWind scaling options, namely on StarWind Grid Architecture. And the subject itself gonna be very interesting, although I am saving the best for live demo, where we could see 5 nodes hyperconverged Hyper-V failover cluster in all its glory. And now you will ask me, 5 nodes, why should we configure that much? And the first thing that comes to mind is maybe lack of compute resources, lack of storage capacity, and the redundancy. Because unfortunately traditional 2 or 3 node cluster configurations do not provide sufficient redundancy for such independent workloads like, let's say, BDI. And then we see data resilience and fault tolerance capabilities are gradually coming to the fore. In other words, the loss of couple nodes shouldn't result in the failure of the whole cluster. The next important thing is performance. There is increasing tendency among practically all well-known storage players towards using some kind of the cross-node erasure coding technology. In short, it is a pretty smart method of data protection where your data is broken into the fragments, encoded with redundant data pieces and stored across a set of the nodes. This approach is often used instead of traditional RAIDs and is intended to reduce the time required to reconstruct data. But at the same time, it may lead to the degraded performance in the event of losing one or multiple nodes that are participating in a failover cluster. Just because the data needs to be rebuilt then, so as I mentioned before, you get low performance during this period of time. StarWind Grid Architecture aims to solve these issues. By the way, for those of you not in the know, grid storage is a general term for any approach to storing data that employs multiple nodes interconnected so that any node can communicate with any other node without switches involved. Alright, go ahead. For your attention guys, this is a quick overview of today's topics. First of all, we'll find out how StarWind scales. Then we'll look into StarWind Grid Architecture, and finally we'll see the failover cluster configured using StarWind Grid. But I want to start small talking about StarWind Virtual Sun itself, just in case some of you are not familiar with our product. So StarWind Virtual Sun is a free software-defined storage solution that eliminates the need in physical SAN by mirroring local disk and flash between its servers to create a high available and fault-tolerant storage pool. Any reputable SDS should scale no matter what. And StarWind offers you 2 scaling options. Scale up enables you to add individual hardware components to each node according to your needs, so you can safely add additional RAM modules, disks, flash when it is necessary. But this approach has physical limits. For instance, once all disk, CPU, PCI, and RAM slots are occupied, it's getting complicated and practically impossible to increase the capacity or performance by adding components. So you then look into a scale-out approach that solves these issues. And the main idea behind scale-out is to increase both storage and compute power by adding additional nodes instead of adding individual components. This way, you improve reliability of the whole system since the data may be spread across multiple nodes. And the procedure itself assumes reconfiguring storage replicas and can be done without any downtime. So you simply add a storage of the scale-out node to the existing pool, or in case of two nodes replication, you break it into the parts, replicate each part to the partner nodes, scaling the system on grid. And the greatest benefit from this approach is data locality when your virtual machines, roles, or applications have the shortest way to the storage, thus operating with considerably less latency and as a result with high performance. Let's have a look at the diagram at the bottom. It illustrates, I would say, not only the general concept of the grid architecture, but also shows how the high availability subsystem is configured. We have each single LAN mirrored between two neighboring nodes, so each of them contains the consistent data which is syncing all the time. And, this gives you great performance and high resiliency, as I told you earlier. So the system can easily tolerate losing up to 15% of the nodes without any downtime at all. And here's how StarWind deals with this such scenario where you lose the nodes along with their partners. But even then, StarWind wouldn't let a cluster die. Portion of your production is still running and the cluster is functioning. Well, let's then jump into our demo environment and see how it works. Alright guys, so please welcome our live demo environment where we have a great chance to see all that stuff in action. So here it is failover cluster configured by myself. So let's then quickly overview its configuration. So as you can see, it consists of 5 nodes and all of them now are up, right? So let's then go ahead. As for the storage, we have 5 cluster shared volumes created. So again, as you can see, CSV12 is replicated between first and the second node. CSV23 replicated between second and third node, and so on and so forth. Then we just a second, let it load it. Come on. Alright. Here we go. So and let's then have a look at the virtual machines we have here. So the virtual machine number 1 was placed on the CSV1 and VM number 2 was placed on the CSV2. So in this way we distributed the workload across all the nodes. And as for the compute resources, VM1 now is running on the first node, VM2 on the second node, and so on and so forth. Right, so now we're gonna see the failover capabilities of the presented system. So I simply gonna shut down one or even 2 of these nodes, and then we could make sure that cluster is still up and running and your VMs weren't affected at all. So this is the main idea behind StarWind Grid Architecture. In short, this system can tolerate losing up to 2 nodes without any downtime for your production, and also without any performance compromise. So your performance wouldn't be degraded at all. Right, so this is all still in theory, so let's then get started. But first of all, I would like to elaborate a bit on the storage part of our cluster. So, as I've mentioned before, all of those cluster shared volumes were created on top of StarWind virtual devices. Yep, so let me then show you the StarWind Management Console. So this is uh, where we are able to create new virtual devices and monitor the storage. Let me remember, if I'm not mistaken, I have it installed on the first node. Now we on the second node, and the consoles should be installed on the first one. And this is its IP address. Just a sec. I'm gonna RDP to it. Here we go. So this is our first node, and just right before us, StarWind Management Console. As you can see, we have just the second server already connected. So let me bring the rest ones up. Oops. That's strange, you know. Never mind. Let me go further. Oh, I got it. Looks like here they are wrong IP addresses. Let me try to re-edit certain first node once again. Just, in order for you to better understand the general concept of StarWind Grid Architecture, so I'm gonna add the third node. Let's try to do this using its DNS name. Here we go. And the first node. Alright. Now it looks better. So, as it was displayed in Failover Cluster Management Wizard, we have these virtual devices that is already replicated to the partner nodes. So again, as you can see, each node contains, and each node is sharing at least two LANs. Yep. And each of these nodes can interconnect with the other nodes, right? And all of these cluster shared volumes were already presented. I mean, all of these virtual devices were already presented as cluster shared volumes to our failover cluster. And talking about the procedure of creating LANs, it is very simple and pretty much straightforward. First of all, you create a standalone image file, and then in order to make it HA, you simply replicate it to the partner nodes, specifying corresponding synchronization and clients networks. So we could go replication node interfaces and see all of this, all I said. So this network is responsible for synchronization, just because, as I already told you, the data is synchronizing all the time. So each packet of data should be synchronized immediately. and this network, we use it for heartbeat purposes, right? Okay, so let's then get back to our failover cluster, to the second node to be exact. Right, so what we're gonna do? In order to check the failover capabilities of this system, we should shut down at least 2 nodes. I don't know, let's choose the first one and maybe the third one, right? So now I'm gonna get back to the first node and simply shut it down. Okay. Let's then wait a bit. Now it is listed as draining. Okay, so we got it down. Let's then have a look at our virtual machines. So as you can see, the live migrating process has been triggered. Now this node is migrating, this virtual machine is migrating to the partner node, to the second one. Alright, so it is a bit laggy, I don't know, most probably just because of let me think. Guys, to be honest, it is a nested configuration, deployed on ESXi hypervisors, probably just because of it, I don't know. Let's wait a bit until it is loaded. It's getting weird, Here we go. Okay, so this VM that was sitting on the first cluster shared volume and was running on the first node, and now it has migrated to the partner node. So everything seems to be fine, and then have a look at our cluster shared volumes. So this LAN has also migrated to the partner node. All right, that's great. Okay, let's then shut down the third node. But first of all, I need to RDP to it. Right, so here it is our third node. Okay, let's then shut it down. Let's see. Okay, so now the third node is listed as down, but let's then check our roles. Okay, so as far as I understood, this VM that that was residing on the third node, the node which we shut it down actually. So now, as you can see, it has successfully migrated to the partner node and continue operating from there. Okay. So as you can see, StarWind Grid Architecture can provide the highest resiliency of your data, and in this configuration can tolerate losing up to 2 nodes without downtime for your production. Even in case we will shut down the third node, so you will lose just the one virtual machine, while the other ones would still up and running, and without any performance issues. Okay, so yep, looks like our webinar comes to the end, and I wanna say thank you guys for your attention. This webinar would be uploaded on our website very soon. I guess it should be tomorrow morning. So please stay tuned and have a great day. Bye bye.